Next is Felix Schwyzer. He is a senior data scientist at CrowdStrike, where he is building innovative technology to detect and prevent cyber attacks. Before that, he was a threat researcher where he reverse engineered complex malware. That sounds super interesting, and I'm looking forward to your talk.
Thank you very much. All right. Good afternoon, everybody. Thank you very much for joining. So let's dive right into it. So what we're going to want to take a closer look at today is how CrowdStrike basically leverages machine learning to massively increase cost for adversaries. So maybe before we dive in, we want to clarify what we mean by adversaries in this context, right? So we're in the cybersecurity realm. So adversaries in this context are e-crime actors. So they're in it for financial gain, for example, by deploying ransomware and so on. And on the other hand, we have nation-state actors who are in it for various motives, but also mainly for espionage. As a concrete example there, for example, I'm sure you've heard this was covered in the news extensively during the past few years. So we have Fancy Bear, or all the bears that are coming out of Russia that have targeted German government entities. So CrowdStrike, since day one, basically has put a major focus on understanding who these adversaries are, how they're operating, what their TTPs are, so their tactics, techniques, and procedures. And this has allowed us to build, off of that extensive knowledge, defensive technologies. And in the space of machine learning, what we're talking about today, this allows us to strategically deploy and position different machine learning models within our defense systems. So that's what we're going to be taking a closer look at now. All right. These screens are pretty small. I hope you can see this in the back. But this basically is an overview of how CrowdStrike uses machine learning models across the Falcon platform. So that's our endpoint protection product. So at the left side, we do have pre-execution detections. So that's our first line of defense, basically. These are file-based classifiers, which will predict on whether a file is malicious or benign. We will get into more details in the following slides. And then if we look at the center of the slide here, this becomes important when you take into consideration that nowadays about 70%, and that's a very large number, of attacks are fileless attacks, right? So you don't have this traditional malware deployment onto an endpoint, but rather see attackers use using vulnerabilities in a system and exploiting those, and then use existing tools on the systems for basically achieving their goals. So in that space, we do have basically two components. I'll be doing a deep dive on AI-powered indicators of attack. So that's an innovative defense system that CrowdStrike is rolling out to customers shortly. So basically, these are behaviors which we use machine learning classifiers for to determine whether such a behavior is malicious or benign. And we also do have behavioral composition there. The idea there is basically to create high-fidelity indicators by combining, in the case of file-based attacks, sometimes you have these, or oftentimes you have like these interwoven sources of information of file-based and behavior-based, right? So we combine results from sensor ML, cloud ML, and indicators of attack. This then feeds, and I won't go into much detail here, but this would, for example, feed into CrowdScore, which is a system that indicates whether an endpoint is part of an incident. And it's also, these indicators are also extensively used by our threat hunting teams. So Falcon Overwatch, these are highly specialized domain experts, analysts that try to uncover the stealthiest attacks we see, track active intrusions, and then also stop them. So let's take a closer look at pre-execution detection. So as I mentioned, this is the first line of defense. So as a concrete example here, you would have an e-crime actor, for example, who wants to deploy ransomware in a system for financial gain, obviously. And as a first stage, they would try to get a loader, for example, so an executable onto a system, and then have that as a downloader to further download additional malware components. So what would happen? This would land as, for example, as an email attachment on an endpoint. Then pre-execution, right? You would have feature extraction being performed on the endpoint, and then have the model classifier. And if a determination is made that this is a malicious file, you would then block execution, prevent execution, and quarantine, right? So these are the simple cases, right? And noteworthy there is this needs to be blazingly fast, right? Because you don't want to interfere with workflows on the endpoint. So these things are done in milliseconds, right? They're optimized for the endpoint, so very little overhead there. And we also do have these on all major platforms. So Windows, obviously, and also Linux and Mac OS. In the case where sensor ML is unsure or not sure enough to outright block the execution of a file, we do reinforce the sensor model with cloud-based models, which are a bit slower, but do extract more information and are larger models. All right, so let's move over to runtime analysis. So as I mentioned before, our threat intelligence team, our internal teams tell us that 70% of all attacks nowadays, and that's a very large number, are fileless. So what do we do in that case? So as I mentioned, we do have this approach with IOAs and indicators of attack, and also AI-powered indicators of attack, where, for example, you have an attacker coming in and then, for example, make use of pre-existing tools on the platform, for example, to create a connection to a command and control server. And we do combine these events, send them to the cloud, and then have various models in the cloud to detect such behavior. I'll go into a bit more detail later on. And as mentioned before, we also do combine intelligence from file-based and fileless, basically, ML models to maximize detection fidelity. All right, so before we can look at AI-powered indicators of attack, we want to take a quick look at the more traditional indicators of attack. So we've used them in the product since forever, basically. So these are, as you can read in the subtitle there, IOAs are unique chains of events that signal active attacks to enable a proactive defense. So if you look at a attacker kill chain, and this is just one example of a kill chain, right? But an attacker has to go through various stages on an endpoint, or basically infiltrating an endpoint, and then go through various stages to achieve their goals. So this starts at reconnaissance, right, where an attacker would be, for example, mapping out a network and identifying vulnerabilities in that network. Then at the weaponization stage, tools or exploits would be selected for successfully exploiting such a vulnerability. Delivery would happen. Then exploitation, obviously, to get an intrusion into a system. And exploitation can also contains elevating privileges. So this is important to be able to basically create persistence on an endpoint. And once persistence is created, you would oftentimes see, or in most cases, a connection back or establishing of a connection back to a command and control server. That command and control server basically allows the attacker to control the infected host by sending instructions. Oftentimes, this is also used as an exfiltration channel. And then depending on the attack and where the initial host lies, you would also see lateral movement. So in the case of an e-crime attack, they're trying to spread ransomware, for example, you would try to map out the whole network, right, and reach as many hosts as possible for then encrypting data. And in the case of a espionage case, oftentimes you would have an intrusion on some host, but the interesting data would lie in a completely different host. So you would see the attacker basically moving laterally through the network. So these more traditional non-AI indicators of attacks, basically they're description of behaviors. So we see here code execution, persistence, stealth. So if an attacker tries to stay under the radar, establishing connection to a command and control server, or also lateral movement. And this as opposed to indicators of compromise, which, for example, would be malware signatures, IP addresses of command and control servers, and so on. All right, so now that we have an overview of indicators of attack, let's move on to this new innovative technology that CrowdStrike is rolling out now. So these are these so-called AI-powered indicators of attacks. For operational security reasons, I unfortunately cannot go into too much details in terms of what the architecture looks like. But basically, we do have sensors installed on all endpoints, right? That sensor collects data on the endpoints that are relevant to discovering, stopping attacks. They're packaged up as events, sent to the cloud. In the cloud, we have various machine learning models that then take these events and predict on those events. If these events or this combination of events is basically considered malicious, a detection will be fired. So as an example, we have an attacker that uses a vulnerability in a system to get a foothold in a system, and then uses pre-existing tools on a Windows host, for example, to let's say elevate privileges or establish a connection to a command and control. You wouldn't have any malicious files on the endpoints per se, right? So what you need to look at is at behavior that you can observe on an endpoint. And for example, one source would be process trees, right? So you see what processes were created, how they're related to each other. These events get aggregated, get sent to the cloud, and then we have a dedicated machine learning model that specifically looks at process trees, makes a decision on whether these are malicious. If they are, detection is fired. And obviously, you want to have these detection fire as early as possible in the attack process, so as early on as possible in the kill chain. But like we said, an attacker has to go through various steps, and as illustrated on the previous slide, to achieve their goals. So we try to detect as early as possible, and basically the end goal there is to stop a successful breach. Another example would be where you would, for example, have a malicious script being executed on an endpoint, but that never touches disk, basically, right? So you don't have a file-based defense, but it's executed or loaded directly into memory, executed from there. We would have events that aggregate relevant information on script execution, and then send this to the cloud, including the deobfuscated script content. And then what would happen, you would have a machine learning model, one that would look at the script content, one that would look at the behavior that you saw exhibited, and would combine that information to make a decision on whether this script is actually malicious. If it is malicious, you would basically stop this pre-execution and generate an alert. All right, so before we move to Q&A, and I think we do have a few minutes, just to re-emphasize, so to be able to stop these breaches pretty early in the kill chain, to know where you want to deploy these ML-based systems, you need to have a very strong understanding of how these various adversaries operate that are attacking your customers. Thank you very much, and I think we do have a few minutes for Q&A.